Hello everyone, this is day 19, question 1 of our lead code activity. Final prices with a special discount in shop. Now, you are given integer array prices where prices I is the price of the item in the shop. Okay, there is a special discount for items in shop. If you buy ith item, then you will receive the discount equivalent to prices j, where j is the minimum index such that j is greater than I, and prices j is less than equal to prices I. Otherwise, you will not receive any discount at all. Return an integer array answer where answer I is the final price you will pay for the ith item of the shop considering the special discount. Okay. So first of all, what the question is saying. So through this example, you can see if an item is of 8 rupees, 8 units, we have to find the next smallest next index which is less than equal to our current price, and that will be our discount. So for 8, the next small very next index which value is less than equal to 8 is 4. So for 8, 4 will be discount. So you can see here output 4, 8 minus 4, 4. Now for 4, which will be the very next less than equal to 4, 6, no, 6 is greater than 4, 2. So here 2 is the very next index whose value is less than equal to our current value, which is 4. So 2 will become our discount for 4. Similarly for 6 also 2 will become the discount. And at last for 2 there is no index which has value less than equal to 2, and same for 3. So we simply have no discount for 2 and 3. For 8 we had 4 discount, so that is 8 minus 4, 4. 4 minus, so 2 as a discount, 4 minus 2, 2. 6, 2 as a discount, so 6 minus 2, 4. And 2, 3 have no discount. So this is the question. So how can we solve this? So first of all, there is a simple for I 0 for I 0 to n, nested it for j 1 to n. Check if price I less than equal to price j, sorry, price j less than equal to price I. If yes, then just directly do price I minus price j, and break the inner loop. So again for next I, you will do this. So this is n square. You can see for worst case, what is the worst case? That is a increasing array. So for this, you can see that 1, 2, 3, 4, 5. So for 1, you will try to find less than equal to 1, you will not find. For 2 same, for 3 same. So you'll traverse the whole thing, and so you will get the worst time square time complexity for this will be n square. So this is a valid because if you see the constraint, our length is 500. So 500 square is what? 25 with 4 zeros. 25 with 4 zeros, that is 2.5, 5 raised to 10 raised to 5. So that is definitely less than 10 raised to 8. So even for 1 second, this this solution is valid. But we can, but this is a straightforward simple solution, and we can do optimize this further to time complexity O of n. How we will use a stack? How we will use a stack? So let me do a dry run and show you. First of all, declare a stack. So this stack is declared, and for int I 0 to I less than prices. So we are going to traverse this whole input array. Now, while not empty and prices st dot top is greater than equal to prices I. So first of all, this is right now empty. So if it is empty, we have to just simply st dot push I. We have to push I, not the value. That is, we have to push the index. So what index right now we are at? So I is right now at 0 as the stack is empty. So this whole logic is bypassed direct to st dot push I. I is right now 0, so that is 0 index. 0th index. Okay. So 0 is pushed. Now we again go for, now I is 1. I is 1. So now while st dot empty is not empty, so this is not empty. Okay, this is 1. And prices st dot top is greater than equal to prices I. So prices st dot top. So st dot top is 0. So prices 0. So the zeroth index value at zeroth index of prices is 8. So is 8 greater than equal to prices I? I is what? 1. So is 8 greater than equal to 4? Yes, it is. So we just simply do prices st dot top minus prices prices I. So what we do is simply whatever the discount we have found, we apply that discount. So that was 8 minus 4. So here this will become 4, and we just move. Oh, yes, this will become 4. Now we do st dot pop. So this will be popped, and we push I. So I is what? Right now I is 1, and we go further. Now 6. So now is our stack empty? No. But is the price at our top? So top index is 1. So index 1 means 4. So the price is 4 greater than equal to price I. I is right now 2. So is 4 greater than equal to 2? uh, 4 greater than equal to 6? No. So this logic will be skipped. Directly push I. So I here is 2. Simply 2 will be pushed in the stack. Now we go further. Right now I is 0, 1, 2, 3. So I is 3. Now we do again. While array is not empty, so array not stack is not empty. Yes, stack is not empty. And prices st dot top greater than equal to prices I. I is 3. So here prices I, this will be replaced by 2. st dot top is 2. 2 is index 2. Prices index 2 is 6. So 6 greater than equal to 2. Yes. So we apply this discount to 6. We do it 4 and we simply pop 2. Now notice this is while. So this will not directly go further to st dot push I. After popping this top, we'll again go to this logic to check this logic once more. So is this empty? No. Prices st dot top greater than equal to prices I? Yes, because index I, index 1, st dot top is 1. So prices 1 is what? 4. Prices I is what? 2. So is 4 greater than equal to 2? Yes. So 2 will also be a discount to 4. So 4 minus 2 will, this will be 2. And now we pop this. Now we again check. Is our stack empty? Yes, our stack is empty and this is and. So both need to be 1 but this is 0. So we will simply go further and st dot push I, and right now I is 3. I is 3, and now we go to last final, that is st. Is stack empty? No. But is price at stack dot top e- greater than equal to price I? So 3. So index 3 is 2. So is 2 price I is right now 4. So is 2 greater than equal to 3? No. So we just simply push again, push 4. We push 4. Remember that we push 4. We are pushing the index, not the value. And this right now I was push I was what? 4. And now I will become 5, but that will be, this will be violated, this will, what to say, that we have now traversed the whole array. So this will be, for loop will also be done for, and we simply return prices. So prices was our this array. Now let us see our array is correct or not. 2 4 4 2 4 2 3, 4 2 4 2 3. So our logic and our algorithm both are correct. But you can have a doubt, why is this of n? Here too we are nesting loops. Inside for loop there is a while loop. But think about it. Think about the overall operations you have performed. So tell me, for each index you can just perform one push operation. You have seen this in the algorithm. For each index I have pushed that index just once. And also for while it can also perform the pop operation for each index just once. This can perform pop operation for each index just once. Yes or no? Because see, now if it is empty, then directly push. If it is not empty and price at top is not greater than equal to price at I, then we again push. But if this condition is true, we just simply enter and st dot pop. So think about it. How many push operations and how many pop operations did we do? We do we did exactly, push operations is exactly equal to the size of array, that is n. Yes or no? We have pushed each element just once. Now also pop. So right now we did not pop these two. But let's just say what will be the what is the maximum pop operations you can do. That is also equal to the size of array approximately. That every element which you added to the stack found a price less than equal to its price, so we applied the discount and popped that. The only one will remain, that will be the last element, because of course there is no element further to the last element to find its uh, smaller value. But n minus 1 and n are the same in complexity analysis. So n, so we can also perform pop for n times, push for n times. So even though you are seeing this while loop, this is nothing but, this is not an exactly nested n square type of while loop. Here, either you just simply perform one pop operation, or you just simply perform one push operation. So what will be this? So n n push operations and n pop operations. So maximum operations we can perform are 2n, and O of 2n is nothing but O of n, and that's why this is linear time complexity and not quadratic time complexity. This is not n square, this is n. That the overall total cost of this whole algorithm for an array of size n will be approximately linear. It will be O of n, and this is how we use the monotonic stack to solve the question final prices with special discount in shop. Thank you.